So what we have here in question 19 is that someone has taken a 100 coil spring and apparently being a bit of a psychopath, they've then chopped up that 100 coil spring into 4 bits. So each of the 4 bits now has 25 coils. Now the thing is that when you chop a spring up into little bits, those little bits will have a different spring constant to the original spring from which they came. And in fact, the spring constant of the larger spring, of the smaller springs, will be bigger. So let's just think about how the spring constant will change and just have a look at a simpler example of, say, an 8-coil spring. So here's an 8-coil spring, and let's suppose that this 8-coil spring has a spring constant of 420 newtons per meter, which is just the spring constant of the 100-coil spring in the question. So now if this thing gets chopped up into 2 bits, each with 4 coils, what will be the spring constant of each of these bits? Well, what this spring constant is telling us is it's telling us that if you take this spring and you stretch it out by 1 meter, it will pull back on you with 420 newtons of force. And that's because each of its little coils here get deformed. And when they deform, they like to spring back so that they're not deformed anymore. And to do that, they apply this force. Now, with these little tiny springs, with these smaller springs here, rather, they're not that tiny yet. If we wanted to stretch this little spring by 1 meter, because it's got half as many coils as this long one, that means that each of the coils would have to be deformed by twice as much in order to stretch this spring by 1 meter as the coils in this spring would have to be deformed to stretch this one by 1 meter. So when you stretch this by 1 meter, the coils are going to be twice as deformed, so they're going to apply twice as much force. So here, the spring constant of this one is just going to be twice that of what it was before, because there is half as many coils, and so each coil will be deformed twice as much when this is stretched by 1 meter as the coils in this one will be deformed when this one is stretched by 1 meter. And the same kind of thing happens if you now subsequently chop these 4-coil springs up into 2-coil springs. So I guess we're actually going to get 4 of these. And so once again, the spring constant should double, because if you stretch this one by 1 meter, it will apply a force back of 840 newtons. But the coils in this spring will have to be deformed by twice as much when this is stretched by 1 meter, as the coils in this spring will be deformed when this one is stretched by 1 meter. And so these will apply twice the amount of force when they get stretched by 1 meter. So again, we double the spring constant. And so this is exactly the situation we have in the question, except that in the question, this spring here has 100 coils and these have 25 each. But we start off with a spring constant of 420, and so each of the 25 coil springs will have this spring constant here. Then what happens is that someone attaches a mass on the end of one of these 25 coil springs and sets it into simple harmonic motion. What is the angular frequency of the motion? Well, since we know the mass and we know the spring constant of that 25 coil spring, then we just have to divide the square root of the spring constant. Sorry, we just have to divide the spring constant by the mass and then take the square root, and that gets us to that's about 6.04 radians per second. When a mass m is 46 kilos is attached